Alright, what's up guys? It's Jeff back on the video. Today we're going to be going over integration by parts. Alright, so integration by parts is a way to integrate functions that cannot be evaluated by like U-sub or any of the other methods we've done in class. And so to get integration by the formula for integration by parts, it comes from the product rule. So if you got u times v, the derivative of that, we know that's du, or we know that's like 1 d2, which would be u dv, plus 2 d1, which would be v du. And then if we take the integral of that, like these cancel out because the integral and derivative are opposites. So you get u times v, and that's the integral of this whole thing, equals the integral of u dv plus the integral of v du. If you solve for integral of u dv, that's equal to u times v minus the integral of v du. So that's where it comes from. And I'll just leave it at the top for reference. So it is the integral of u dv equals u times v minus the integral of v du. So if we look at our first example, it is the integral of x cosine x dx, and obviously we can't use a u sub. Like if we tried substituting u for cosine x, you get du over negative sine x equals dx, and then like that doesn't cancel out with anything, so you'd just be left with like x u du over negative sine x, and that just didn't help you with anything. So we have to use the integration by parts formula. So so in this case u would be equal to x, because you're going to want to use the acronym LIPIT to find whatever like u should be. So like if you have a logarithm, u should be like the log, and if you have inverse trig and then a polynomial and then an exponential like e to the x or whatever, and then if you have a trig function, that's like the order of what you're going to want to substitute u in for. So in this case, x is a polynomial, and that comes before trig because p comes before t in LIPIT. So you're going to want to substitute x in for u, and then obviously du equals dx, and then so cosine x would be your dv, and if we integrate both sides, get v equals sine x, because the derivative of sine x is cosine x. And so we can just plug in this stuff into here. So the integral of u dv, so the integral of x cosine x, is equal to u times v, so that would be x times sine x, because that's your u and that's your v, and then minus the integral of v du, and v is sine x, and du is dx. So you just get x sine x plus cosine x, because the integral of sine x is negative cosine x, and the negatives like turn into a positive, and then plus c, and that's your answer for the first one. And so if we go on to the next one, we have the integral of x squared plus 1, right, yeah, and then e to the x dx. So you want to substitute x squared plus 1 in for u, because like this is a polynomial and this is an exponential, and in Lipit p comes before e, so you get du over, what did I do? Yeah, so du over 2x equal false. You get whatever. So you get du equals 2x dx, and then your dv would be e to the x. When you integrate this, you just get e to the x, because derivative of e to the x is e to the x. So we just plug this stuff in for here. So you do u times v, which is x squared plus 1, and v is e to the x, and then subtract the integral of v du, which is e to the x times 2x dx, that's this jump. And you can't, I'm going to rewrite this to be, I'm just going to switch these around because it's easier to look at. So you get that, and from here you can't like integrate this, so you have to use integration by parts again. So just looking at this, here, I'm gonna rewrite this up here so I have space. So we have x squared plus 1 times e to the x minus the integral of 2x e to the x dx. And if we're just looking at this part here, we would have to use integration by parts again to solve this. So u would be equal to 2x, because polynomial, exponential, p comes before e, you know all that. So du over 2, whatever, leave it in x. Okay, so du equals 2 dx, and then your dv again will be equal to e to the x, so your v is e to the x. So we just plug this stuff in again. So we have u times v, which is 2x e to the x minus the integral of v du, which is just e to the x times 2 dx, and then we can pull out this 2, so it's 2 or minus 2 times the integral of e to the x dx, and then it's 2, and when you integrate e to the x, you just get e to the x plus c. But that's just this part up here, so our full answer is this. So you get x squared plus 1 times e to the x minus this entire thing, so you're gonna like subtract all this, so you get minus 2x e to the x plus 2 e to the x, because negatives cancel out, and then plus c. And that is how you do the second one. And yes, that is a lot of work, but there is, hold on a second. Yeah. Okay. So yeah, that is a lot of work, and yes, there is a much easier way of doing all of it using the table method. And so if we go to the back of our sheet, we have the integral of x squared minus 4x times sine 2x dx. So yes, we could do like set this equal to u and then this equal to dv and do all the same thing we did before, but we would have to do it, I think, 3 times instead of, in the last one took 2, and that was a lot of work, so this is going to be a lot of work. But instead of doing all that, you could just say, like, you take one side that you're going to differentiate and one side that you're going to integrate. So, and this would be your u, like, so this d would be your u, and this I would be your dv. And so, like, since this would be what you would put in for u, since this is the polynomial and that's a trig function, you put like what you would substitute for u on the differentiate side, and then put the rest on the integrate side, and then you just differentiate until you get to 0. So like this is 2x minus 4, because that's the derivative of this. And then you take the derivative again, which is 2, and then 0. So notice how we got all the way down until we got to 0. And then we integrate until we reach that same point. So when we integrate sine 2x, we're going to get negative cosine 2x over 4. I'm going to spread this out a little bit so you can see better. So 2x minus 4, and then 2, and then 0. So you're going to negative cosine 2x over 2, and feel free to check that if you want, but it's right. So when you integrate that again, you get negative sine 2x over 4, and then you get cosine 2x over 8 for the last one. So all you got to do is start, this would be positive, this is negative, this is positive, this is negative, because every time you do the integration by parts, like you're subtracting the integral, and so when you do it again, you're subtracting like a subtraction, so that's how it goes from negative to positive, if that makes any sense at all. So the way you do from here is you just multiply the diagonals. So like what you get when you multiply here, you get negative x squared minus 4x times cosine 2x whole thing over 2. And then since this is negative and this is negative, you're going to be plus 2x minus 4 times sine 2x over 4. And then for the next one, you have a positive times a positive, so it's just going to be plus 2 cosine 2x over 8. And then you would multiply this diagonal, but you're multiplying by 0, so that's just stupid. And then you just add a plus c there. So that's how you do it using the table method. And if you had, like if it was a definite integral and you had like, I don't know, like just a to b, you would just evaluate this whole jump, obviously without a c, from a to b. And that's what we'll do for the next one. Okay, so for this next one we have the integral from 1 to 2 of x cubed e to the x, nope, e to the 3x dx. So what you do here is the same thing you did last time. Set your two sides for differentiate and integrate. And so this would be your differentiate side, because this is what you would substitute in for u. That's a polynomial and that's an exponential. So you just set these where they're supposed to go, and then differentiate until you get to 0. So it'd be 3x squared, and 6x, and then 6, and then 0. And then integrate this side, you get e to the 3x over 3, and then again, feel free to check all these, but they're right. So e to the 3x over 9, then 27, and then 81. I'm gonna make this like a table so it's easier to see. Okay, so this is plus, minus, plus, minus, plus, because you just alternate, and then multiply diagonally. Yeah. And so you get x cubed, oops, yeah, x cubed e to the 3x over 3, and then minus, since this one's negative, 3x squared e to the 3x over 9, and then plus 6x e to the 3x over 27, and minus 6 e to the 3x over, that's an 81 by the way, over 81. And I mean, yeah, you could reduce this to like 3 or what, like 2 over 9, and then 1/3, and then like something else, but we're not gonna do that. And so I'm gonna just get rid of this table because it's in the way, and we don't need it anymore since we got all this. And so since we have a definite integral, you just evaluate all this from 1 to 2, I believe. Yeah. And so just plug in 2 for all this, and then plug in 1 for all this, and then just subtract them, and then that would be your answer. And that's really all there is to integration by parts. It's not that hard.